In this video, we are going to create the KeyboardInput class for our game.
That's right. Now, the purpose of this class is to take inputs from your computer's keyboard and churn them out as events that will later on get passed on to our input class, which we haven't yet written.
Now, this is in opposition to the way input handling works by default in XNA, where input is all state-based. The idea is that you, as the programmer, can at any moment in time pull the keyboard or whatever device you're looking at and see what keys are currently pressed or released.
Right. So every single game tick, you'd have, like, just say for the X key, if it's not being held down, every tick gets released, 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 and then you hold it down and it says press, 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 press until you let go of it again. That's a whole lot of pulses. So we're going to use the keyboard input system to narrow that down to just two separate events. Either the key is down, and that's one event, or the key goes up, and that's another event.
Exactly, and we're going to take the code that is necessary to look at those states and to generate those pulses. We'll keep that all contained within the keyboard input class to clean everything up and to make it easier to read those pulses later down the line.
Right.
All right, let's get started with the class itself. We'll go over here to our Solution Explorer, and I'm going to collapse the Content section. Now, we're going to drop this new class in a new folder up here in our game project. I'm going to right-click and add a new folder. We'll call this folder Input. Then inside of this Input folder, we'll add a class, and that class will be called KeyboardInput. Alright, before we get started, we'll do a little bit of cleanup. We'll take out our input sub namespace. We'll drop in a using statement to give ourselves access to the input types that are part of XNA. So we'll say using Microsoft.xna.framework.input. And we will note the fact that the keyboard input class is going to be static. We won't worry about instances with these type of device inputs.
Okay.
Now, before we worry about the code for the class itself, we are going to define a delegate. The idea here is that we want to keep everything inside the input class very keyboard specific. All the keyboard classes worry about is the keyboard, and then firing off pulses to say that a keyboard event occurred. What we're going to do with this delegate is we're going to say in what format these event calls should be, what method signature is required for the communication to go out of the class.
Okay.
So I'm going to make a delegate. The delegate will be void return. We won't worry about our key notice methods returning anything. And we will call the delegate just that. We'll call it key notice. Now we need to define the method signature that will be used in conjunction with this delegate. So we'll specify two parameters. We'll specify the key that was just pressed, or the key that was just, I'm pausing on pressed.
Yeah,
we're going to
whatever key that you're doing something to.
Exactly. We're going to use this in both press and release scenarios. So whatever key is important.
The key in question.
So we'll need to pass that around. We'll pass it as a key, as part of the keys enum. And in addition to the specific key of interest, we will also pass the entire state from which we gathered that key. And that could be useful to someone if they wanted to detect other keys in conjunction with this. Meaning, let's say we listen out for the A key to be pressed, but maybe we want to see if the control key was pressed at the same time to cause something else to happen. So to allow for this kind of functionality, we will also pass a key state. And so that will be in the form of keyboard state, and we'll call the parameter name key state.
Okay.
And that takes care of our delegate. Now we have the format established by which we will communicate. Now we can move into the keyboard class itself. And inside of here there's a handful of fields we need to put together. The first of which is going to be a list. I'm going to go ahead and drop this down, and then we'll discuss exactly what it does. I'm going to make a static list. And this list will be of type keys. So we will put keyboard keys into this list. And we'll call this list bound keys. And then we'll turn around and go ahead and instantiate it right off the bat through the field initializer. Now, the purpose of this list is to give ourselves a finite number of keys through which to look every time we update, when we're looking to see if keys were pressed or released. And the idea is we will only focus on keys that are present in the bound keys list.
Right, only those keys that are involved with our game. So if our entire game was played with like WSAD, just as an example, then you don't necessarily want to monitor the P key or the left bracket key.
And the reason we're doing this, there are other ways to go about getting a list of keys to loop through. One way would be to dump the entire keys enumeration and loop through every key.
Ooh.
The downside there is, one, inefficiency, because you're looping through a whole lot of keys you don't need. And two, you don't necessarily have all the functionality for dumping the enumeration on certain other variants. For example, the .NET Compact framework, if you were to ever target the Xbox 360.
Gotcha.
The other reason is that this makes it easier to use in conjunction with our binding system. This will also follow the same pattern when we start to use our gamepad input.
Okay.
Now there is one more way that we can get keys from XNA's keyboard input system. The key state type can return an array of all of the pressed keys.
Okay.
The reason we're not going to use that method is it requires the creation of an array. And that will generate garbage, and we want to avoid generating garbage during gameplay in our game.
Okay.
So we're going to avoid making an array just to look at keys.
You've sold me.
We'll basically make this list ahead of time and then get back to it later.
Very cool.
All right. The next thing we're going to need is the ability to hold the state of the keys in between updates. So we'll make another static field called, or rather of type, keyboard state. And we'll call this last key state.
And this is, I imagine, what we're going to use to compare against to figure out whether an event has occurred, whether we've just pressed a button or whether the button's gone up.
Exactly. What we'll do is whenever an update occurs, we'll get the state at the time of that update, and we'll compare it with this last key state. And that will give ourselves the difference of when the last update a key was released, and this update the key is pressed, so therefore we can fire off the press event.
Gotcha.
All right. Now we need to define two event fields. So we will make some public static fields. We will specify these fields as events, and we will say that they will be of type key notice. Then we will name them key press, and we will make a second one called key release. So here's really where we put our delegate into action. We're saying that we're going to make some key notice fields. They'll be used as events, so we can, outside of the class, we can tie into them and listen for events. On the inside, we can call them to generate those events.
Right.
Now, I'm going to do something, a little bit of a trick, if you will, to ensure that we never get exceptions whenever we try to call these. Because, of course, if we left the fields as is, and we were to run the game at this point, the key press and key release fields would be null. We have not actually assigned any delegate to them. We have not assigned any functionality to them.
Right.
Therefore, we can't call them. And what we want to do is set up a scenario where we make an empty blank method, assign that method into the delegate, so that way it can be called without crashing the game.
It just won't do anything.
And then we'll simply leverage the fact that events can be multicast. So when we really do assign something to it, we'll have a blank method and then our real function call.
Okay.
So we'll just at that point we'll just never see the blank method again.
Gotcha.
And just kind of a form of insurance to make sure that we can, at any point, call on this event.
Just so that we don't get a null return, which could throw an exception.
So what we'll do is we'll create what is called an anonymous method. We'll set up a method that is unnamed that simply has a given method structure, or parameter signature. So we will do this by saying delegate, open parenthesis, and then we will specify our method signature, which, just to point out how this is working, I'm going to grab our signature directly from the delegate and drop that in. So we're making sure we match our method signature. And we will set the method body just as empty brackets. We could, of course, with our anonymous method here, write whatever statements we would like inside of the method body.
Sure.
In this case, the whole point of this is to act as a placeholder that does nothing. We'll simply put no statements inside of it.
Okay.
And then the terminator to finish off the entire field. And then we'll take this line and duplicate it down to our key release. So what we've done is we have now created and then linked up our events to blank anonymous methods, which means hereafter these events can be called safely without crashing the game.
So they're no longer connected to nothing, they're connected to something that does nothing.
Exactly. Alright, that takes care of the fields. Now we can jump in and begin coding our class. We're going to begin with a method called addKey. This will be a public method. It will be static, no return, and it will be called addKey. And then we will take in a single key in the form of a keys parameter.
And generally, what's this going to do?
This is going to allow us access to this bound keys list, which is not public, so not externally accessible.
Gotcha.
This is the way that we indicate to keyboard input that we would like it to start watching for a specific key.
Okay.
So all we're going to do in here is we're going to check and see if the incoming key is already in the list, and if it's not, we'll add it.
Okay.
So if not bound keys dot contains the incoming key, then we'll take bound keys and we'll add the incoming key. And that should take care of add key.
Okay.
Now we can code in the heart of the keyboard input class. This will be done as the update method. So let's go ahead and drop down our method here. Public static void update. And the idea is that we will call this method from inside of our game, rather, and then in actuality we'll be calling this from our main input system.
Right, which again is unwritten as of this point.
And this will give our keyboard input class the opportunity to pull the keyboard, check all the states, and see if any keys were pressed or released in the current update.
And if so, churn out an event.
Exactly. So we need to set up a state to read what the current state is, and then we'll set up some code between the current state and the last state, which will do the actual checking. So we need to make a keyboard state, and we'll call this key state. And we'll go ahead and set this to be keyboard.getState. So we will sample the current state of the keyboard. Now we will put together a for loop that will let us walk through all of the keys that we're watching inside of bound keys. So we'll say for, I'll go ahead and use the template, hit tab twice. We'll loop using I as our index variable, and we will loop through all of the keys in bound keys. So bound keys.count. Now, for each key, we'll see if the key was either just pressed or just released. So to check and see if it was pressed, we'll look in here and say if key state dot is key down, and then we'll look at the current key from bound keys. So if we look into bound keys sub I, so basically we're saying is that key currently pressed? And we need to check and say, well, if it's pressed now and it was released in the last state, then we can go ahead and fire off the event. So if the key is currently down and the last state is key up for the given key, bound keys sub I.
So that means it just got pressed. Now this is very similar to what we did, wasn't it, in the sound system?
It was. We set up when we were testing manual playback of sounds.
Right, just a way to press keys and make it play noise.
What we did is exactly this style if statement, only we rewrote the if statement over and over again for every key we were looking at.
Right.
Here we're letting a for loop do that for us.
Okay.
Now if we have detected that a key was just pressed, then we will fire off the key press event. So we'll simply make a call to key press. So we'll fire off the event, and of course we need to pass along the parameters that the event is expecting. So we need to pass in the key. So we'll look into bound keys sub I, and we will also pass along the current key state, so that if anyone listening to this event would like to look up further information about the current key state, they're free to do so. Now we're going to put in a case for the opposite. If a key has been held down for a while and it was just released,
Right.
we need to do the reverse of this check. So we'll set up an if statement. We'll look at key state.
You don't want to just copy paste the whole thing and swap the up and down statements?
We could.
I mean, I don't care. It's cool if you want to type it all out again.
We'll try it this way. It might actually make more sense with visually seeing them swap around. So if we just duplicate this and say that, okay, instead of key press, we're going to do key release. Now, the state we're looking for is to look at the current key and see if the current key is actually up. So if it's up right now, and in the last state it was down, then you could say it just went from being down to being up, and that's what we're considering to be a release.
Right, then we fire off our other event, which is key release.
And then the one last thing we need to do inside of update is make sure that we remember to update our last key state.
Right.
So once all this is done and considered, we will update last key state to whatever the current key state is, and then we're ready to go for the next check. So we'll build briefly, make sure that there's no syntax errors. Everything is looking good inside of our keyboard input class. So let's very briefly jump into our game class and let's test out our new keyboard input. I know it's not going to find its final home inside of game,
right,
but we would like to make sure that everything is functioning properly before we move on.
This is going to be some temporary code we're going to put inside the game class to make sure everything's working, and eventually it will be code that will be housed within the input class.
Exactly.
Which is coming right up.
So the first thing to address is the input method inside of our game class. Or excuse me, our initialize method, rather.
I was with you.
All right, what we want to do is we want to listen for those events coming out of keyboard input and point those at some methods. So what we'll do is we'll look into keyboard input and we'll address the key. I'll do the key release one first, and you'll see why in just a second. We'll address key release. I'll hit plus equals, and since Visual Studio has noticed the fact that that key release field was an event, it's now hinted that maybe we're trying to make a new key notice handler. And that's exactly what we want to do. We'll hit tab, drop in the handler, and it's also suggesting that, we don't really have a method to handle it yet. Would we like to make one called keyboard input underscore key release? And we would. So we'll hit tab one more time, everything will get dropped in, and we're ready to go. We now have a handler for our event, an actual
really
method
too easy.
Created. Now I'll turn around and handle key press. So once again, keyboard input, the event is key press, plus equals, we get the hint for the event handler, we get the hint for the method, and we get the method dropped in. You'll notice now key press, the new method gets created directly after the method we were in. So now key press resides on top of key release. That's the only reason I did release first, is just so that these methods would stack.
Okay.
Just to save myself the 2 seconds it would take to swap the order.
Which you've now killed by explaining it. I'm just giving you a hard time.
Excellent. Okay. So inside of these methods now, these methods that will be handling our events, I'm going to put a simple log writeLine call in place just to visually indicate that something is happening. So we'll say log writeLine, and we'll dump some message to the screen, possibly key pressed. And then we'll say that argument 0 is going to hold the key. So we'll pass in, looking at this parameter here, we'll just pass the key parameter into the log call. And then we'll do the same for released. I'll just copy the call to log.writeLine. And we'll say, in the case of release, we'll say key was released.
Released did. I like that. You should have left that.
There we go. And all that looks good. Now, of course, nothing is really going to happen if we left it alone, because we do need to tell the keyboard to recheck the state every update. So we need to make sure we jump down here to update. And we'll go in here and say keyboard input dot update. And then it can be responsible for checking the key states. Now, at this point, there is still one last thing to do, and that is tell the keyboard input class exactly what keys it should be watching for. Because if we try to run the code right now, keyboard input, well, we haven't touched bound keys yet, it's going to have 0 elements in it. If we loop over zero elements, we don't check anything. So before we actually set these up, let's take our keyboard input and add some keys to it. Let's add maybe the A key as keys.a, and maybe a couple other keys, possibly keys.z and keys.space. So we'll watch for these three keys. When we run the game, we should see each of their press and release events being echoed out to the screen. So let's run and test. Alright, let's press the A key. A key was pressed.
Nice.
Let's release the A key. A key was released.
Very
so
nice.
Z key and space.
Seems to be working.
So now we're free to press these however we like. We see each event getting shown and reported through the event. And also, despite the fact that the game is running at many updates per second, we can press the key. As long as it stays pressed, we only read it event by event.
Gotcha.
So we get one event per press, and in order to re-trigger a pressed event, we have to release and then repress the key. And now we've got this all placed into a single module, keyboard input. So all we have to worry about is what keys would we like events from, and where would we like to point those events at, what method handlers.
Seems to be working pretty well. Now, are we going to leave this code here inside the game class?
No, we're going to wrap up this video by removing our test code.
Okay.
Since the idea is all of this type of functionality, adding in keys, looking for handlers, all of that is actually going to be handled in the input system. So we're going to wipe out all of our test code. That means inside of initialize, we're going to take out our keyboard input add keys lines and our keyboard key press and key release. We'll take those out of initialize. We will wipe out our keyboard input handlers. And we will wipe out the call to keyboardinput.update. And then maybe build one last time, make sure we haven't broken anything. Everything is working well. So at this point, we have written and tested our keyboard input. Everything is working perfectly.
Awesome.
So that will wrap up this video.
Excellent.